Lesson 3 examples. Writing the inverse and graphing exponential and logarithmic functions. Let's start with an example 1. f of x is equal to 2e to the power of x plus 3 minus 1. This is an exponential function. We need to find the inverse of this function, and we know the inverse of an exponential function is log function. Y equals 2e to the power of x plus 3 minus 1. Y becomes x, x becomes y, and rewrite this way, and add 1 divided by 2, that you get x plus 1 divided by 2 is equal to e to the power of y plus 3. Since it is basis e, this is a natural logarithm function, so apply ln on both sides. When you apply ln on both sides, you get y plus 3. This y plus 3 goes over here. Y plus 3 is equal to ln x plus 1 divided by 2. And use the right notation for inverse function. F inverse x is equal to ln, move the 3 to the other side with minus 3, ln x plus 3, x plus 1 over 2 minus 3. So this is going to be the inverse function. So we are going to graph this function right here. We graph the original function and we graph the inverse. These are the attributes of the original function and for the inverse. And we know the parent points of a log function. The parent function is negative 1 over e, 0, 1, and 1e. And the transformation rule is x minus 3 and 2y minus 1 based on the a, b, c, d values that you can calculate. The a is 2, b is 1, and c is negative 3, and d is negative 1. Apply those, and the transformation rule is going to be x minus 3 and 2y minus 1. So apply those transformations for these parent points. You get negative 4 2 over e minus 1, negative 3 1, and negative 2 2e minus 1. Plot those points, and the attributes are domain x negative infinity to positive infinity, range negative 1 to infinity, x-intercept is ln 1/2 minus 3 comma 0. You can find the x-intercept by setting y equal to 0, setting 0, and do the math, find the x, and the y-intercept is calculated by setting x equal to 0. Replace that x by 0 and you calculate for y. That is 0 to e to the power of 3 minus 1. And asymptote is y is equal to negative 1, and it is an increasing function. Now, we have already found out what is the inverse function, which is going to be f inverse x is equal to ln x plus 1 over 2 minus 3. Let's talk about that and make the parents and parent points and the transformed points. We know the parent points of the original function, which is the exponential function, is this, and just flip those and put it over here. You can put 1 over e negative 1 and 1 0 and e negative 1, sorry, e1, and the transformation is 2x minus 1 y minus 3. It is very similar to this one. You can see that 2y minus 1 becomes a 2x minus 1, x minus 3 becomes y minus 3 because it is inverse. X and y values switch. Okay. And those points are, you can just flip. You can either calculate using this rule, or you can flip these 3 sets of points and put it over here. That is good. That's going to be the transformed points for the inverse function. Plot those points, and you can see that that's an increasing function. The asymptote is x is equal to negative 1. Let's look at the attributes quickly. Domain is negative 1 to infinity. Negative 1 to infinity. Range is all real numbers. X-intercept is calculated by setting y equal to 0, which is 2e to the power of 3 minus 1 and comma 0. Y-intercept is calculated by setting x equal to 0, 0, ln 1/2 minus 3 is going to be the y-intercept. Asymptote is x equal to negative 1, and this is an increasing function.